So I want to welcome Sarah Hirsch, who's a social science researcher at Stanford University, who's agreed to give us another lovely talk on regular expressions entitled The Magic of Regular Expressions. I want to share a couple things before we dive into the talk. So if you aren't following us on Mastodon, you can follow us. We're on the Fosstodon instance, free open source software, Fosstodon, and our account is rug@HDSI. If you're interested in helping us organize events, please reach out to us. And also, if you're not on our email list, just go to our website, rug@hdsi.org, and then go through the new member sign up survey and share your email with us so we can get you on our email list. But with that, I'll turn it over to Sarah, and Sarah will share some data sets that will work together interactively to clean with regular expressions.
Yes. Hi. Thank you so much, Christian and Nicole, for inviting me to do this workshop. I'm really excited about it. I get to put on my ultra nerd hat, and I'm very happy there. So welcome. I think that regex is a really cool. Once upon a time, I was a translator and more in linguistics and kind of looking at these more precisely codified ways of looking at language has been very interesting to me. So my plan is I have a presentation prepared, and there's also tutorial with exercises where you can follow along. The data sets are in the chat. If people come in after, please feel free to resend those links. They're taken from a data set of YouTube comments that I got off of Kaggle. I have the link so nobody goes unsighted. What I really love is lots of interaction. If you have any questions, if you're confused about anything, if there's something you want to know more about, please feel free. Because I think this for me was kind of the step between where I felt like I was kind of just picking dplyr commands, and to where I felt like I was really programming. This was kind of what moved me from point A to point B. And being able to make that leap has made the rest of my coding so much more efficient. Anything else before we start? I don't think so. Let us dive in, and please tell me if there's something wrong with my presentation. If I'm not sharing the screens correctly, somehow there always manages to be a bug with that. But I'm going to try to share two screens at the same time. So we will see how this goes. Okay, can you all see both of my screens? On the right should be my presentation, and on the left should be my RStudio.
Yes, I can see them. Okay, now I can see your presentation quite large. Okay, this is good.
Okay, great. So the presentation's large and the RStudio is in the other panel.
Yeah, it's just the font size is pretty small on the RStudio window to see both of them. Just so
okay,
you know.
I'll amp that up in a minute. First, we're gonna go into the presentation, and then when we have to switch between the two, I won't put you all in reading glasses ahead of time.
Great.
Before your time, that is. So the magic of regex. And some people say regex. I am a descriptive linguist. Whatever comes more easily to you, I think is what you should use. So there we go. What is regex? It is short for regular expression. That's why I say regex, which is a system of codes used to generalize character strings. If anyone on this call has ever worked with, for example, address data right? Where people fill out forms, or like any kind of forms with open response questions where people put in typos. They write their name all kinds of different ways. You can see maybe why it might be good to be able to regularize these forms of writing to make them easier to parse, right? It's used in a lot of programming languages for a lot of things. And there are different types, there are different regexes, which is the plural. And it is extremely useful for a lot of things, some of which I'll go into here. That you can find and remove or replace systematic typos, especially like in those forms that I mentioned, perform fuzzy searches on the data. If you want a pattern that matches a range of different numbers, for example, that are all in text, you can use regex for that. Conditionally loop through character strings. They're also good for API calls, a lot of other stuff. But just really anything you can think of. So since this is a full-on workshop, you're going to learn about regex. And also, I find this useful for troubleshooting. I wanted to mention a little bit about the different regex engines. There's generally the most powerful one, recognized as the most powerful, is Perl, which is where you get those look aheads, look behinds, atomic groups, non-atomic groups, all this stuff. But in R, the default is actually TRE, which is a slightly less powerful version of a slightly less powerful regex engine. And you also have this option of fixed, right? So under each of these headings, I've put Perl equals true, fixed equals false, like the different values that these arguments can take. And this is how you activate each type of each regex engine type within R, right? So Perl true, fixed false is Perl, Perl false, fixed false is TRE, Perl false, fixed true is fixed, and Perl true, fixed true is impossible. It will give you an error, right? Fixed is it just literally takes whatever characters you put between quotes and it looks for those. So you can't do any like special character classes or any of the other things. Sometimes it can be helpful when you have funky characters that you want to look for and you don't feel like grappling with the escaping special characters and Perl and stuff like that. Okay, so how do I use it? I wish I could go into absolutely all of the rabbit holes that exist about how to use regex and the different character classes and all that. For right now, I'm gonna stick with some of the basics. First of all, regex is not a package, right? That's, I mean, just kind of as a way to kind of like put yourself in the right dimension for like how to think of regex within our programming language. It doesn't belong to, for example, dplyr or data table or base R. I mean, I guess it is a part of base R, but it's not a package in itself. It's more, if it's a functionality. And there are certain functions that automatically wrap character strings in this regex function. There may be some limits to that, but the point of this is that you can use it with anything pretty much. So some of the symbols that I use most frequently, so apart from all of these whatever character comes off of your keyboard. We have these special characters or character classes that are represented by a backslash and these different codes, right? So 2 backslashes and a lowercase d are digits. 2 backslashes and an uppercase d are not digits, right? So that's the pattern. So W are word characters, capital W are not word characters, right? And technically the syntax is 1 backslash and a character or some kind of, one of these codes. But because of how R works, you need the 2 backslashes. So that's just how I wrote them, so you don't get confused. You can also do \s for a white space. Another way of writing character classes is putting them in brackets, such as this alpha notation that I had there. And then below those are symbols used to indicate how many repetitions of a certain pattern you would like to use, right? So the plus is 1 or more, the asterisk is 0 or more, and then you can use brackets to indicate some kind of range or interval. And then the final row are what are called anchors. Again, I will come to you as soon as I finish the slide. And so the caret is for the beginning of the string. So if you put, if you write a caret and then whatever pattern there will be, the function will look for no intervening characters between or no characters prior to the pattern that you enter. And likewise, the dollar symbol will anchor it to the end of a string, right? So there will be no following characters. So yeah, if any questions are concerns about how this all works, we will go right into that. But otherwise, I wanted to ask if there are any questions that we have right now, anything that's unclear. I think, Gael, did you change your mind?
Yeah, I had a question. So it's kind of is regex a class within a language, or is this like a whole other language?
This is,
because you know how like other languages have like the math class, that sort of thing. Is this like its own separate class, or is it like its own separate language? Whenever like I'm not getting right now.
it's kind of, it's not exactly either. It's definitely not a class, right? Because the class that it works in would be string or character, depending on what language you're in. It's kind of a language in the like more basic sense of what a language is, but it's technically an engine. So it has it's a searching system basically. But I think the best way to think of it is like a language.
Okay, thank you.
No problem. Anybody else? I don't see any hands. So. Okay. And so I've just a real quick dip into the world of look aheads and look behinds. This is a special part of what Perl offers. And this basically allows you to say, I want to find such and such pattern that after such and such pattern, or comes before such and such other pattern, or does not have another pattern before it, or does not have this other pattern after it, right? And I'll do some demonstrations with this because it's a little bit confusing, but it can be really helpful with some of these cleaning tasks. So we have look aheads and look behinds. So the look aheads look for something that follows the pattern that you're looking for, but it doesn't capture it, right? Which will makes a little more sense in certain functions than others. And then the look behinds are the opposite, right? Where whatever pattern you're looking for is preceded by something. And then the negative of those are not followed by or not preceded by. So this is the syntax for them. All of these look aheads and look behind starts with this little, they're in parentheses, they start with question mark. And then, so ahead you get the equals, right? And then behind you get the not, basically. And then the look behind you get before equals, and then negative look behind you get the before not. And then these dots are whatever the pattern is. So now we'll get into some different, any questions about look aheads and look behinds? And I will caution that that's a very long, deep, dark rabbit hole. But if anybody's a little confused on kind of the broad strokes, go for it. So what I wanted to do was look at a few different use cases. So first, what I'm going to do is go through these use cases and look at some very basic examples. And then once I've done that, we're going to go back and start to look at how these things can be pulled together to use when cleaning data in, more complex ways. And at the end, we'll talk a little bit about non-English characters, because oddly enough, a lot of the world does not speak English, right? Very much tongue in cheek there. But it's, I think it's an important thing to touch on. We'll also do some troubleshooting stuff at the end. So pulling variables by pattern. This is a very basic task, but if anybody here has worked with data sets with 100 different columns, the last thing you want to do is to be typing out the name of each column that you want. So the steps, which are very rudimentary, right? But just so we're all on the same page, are to identify or generate the naming conventions that you want for, or have for your variables, then filter column names by pattern, and then subset the data column name vector, right? So let's look at a very quick example of this, and I will zoom in a lot. Christian, how's this looking? Does this look like a more reasonable font size?
It's still pretty hard to read. You're gonna have to zoom in a lot.
Okay.
Maybe just hold like Control+ for a minute or something.
All right. That's not what I want.
Oh,
Okay, here we go.
okay.
Yeah?
Getting there. Yeah. It's tough with the two monitors because it shows on one window for me, and yeah.
Oh, I see. Okay.
Would it be better to
Well,
reshare
here,
just one screen? Or do you need to flip back and forth a lot?
I'll do the simple examples on both screens, and then when we get into the more complex stuff, I will I'll share on just the RStudio. Does that sound reasonable?
Yeah.
Hey, Sarah.
Yeah.
Could you just press Control+ one more time? I think that'll be enough.
One more time will be okay.
Yeah, that's
How do we
fine.
feel about?
I just have to lean in to my screen a little bit, but I can see.
Okay, here we'll go. We don't really only need, is this?
Oh, there we go. Yeah,
Yeah.
that's great.
This is
Okay.
great.
Okay. All right. Yeah, sorry about that. I have a very different a very different viewing experience. So I'm glad that this is working for everybody. So for these quick examples, I'm gonna go over the dplyr code. I highly recommend learning, if you're only comfortable with dplyr, I recommend learning data table or at least base R, because especially when you're dealing with strings, if you're dealing with large data, it starts getting slow. So for the more in-depth examples, I'm going to be relying more on data table, but so we're on the same page, we'll start off with dplyr. So loading the two data tables. So here is, there we go. So this is, so you can also look at the presentation, which has the code snippets as well. So in order to, so here, let's just look at the names in the first data set, right? So here are the column names. We got video name, channel name, comment ID, username, comment date, likes, and responders. It agrees me that these are not cleaner, but I didn't clean them on purpose. So just as a disclaimer, they should be clean. They're not, but so in dplyr, you get the pipe structure and then select those variables. You can use matches with these regex expressions. It contains will not work because that just works with fixed. But matches will allow you to be a little bit more flexible. And so does anybody have an idea of what this pattern will match? Okay. I will tell you then. It will match two M's in a row, right? So this, if I wrote it right, it should bring back comment ID and comment. So here we are. We have comment ID. And then here we have comment, right? And then this is, this code is a little bit different. This will just bring back the names. But here we have comment ID and comment. And just real quick on the structure, these are the column names, right? This is the subsetting condition, where I use grepl. So it's grep logical. And here's the condition, or here's the regex expression. And then here is the data that I'm putting into this, this function, which will return a vector of a Boolean vector, right, of trues and falses, and then subset names by the Boolean vector. All right. So, and then we can correct systematic errors. And so to make this just more visual, I'm thinking, you know, you see people who write their name, you know, Sarah, right? And then you have like Sarah, right? And then you have like, you know, whatever, Sarah, you know, and so you end up being like, I'm pretty sure all of these people are the same person. They live at the same address. Let's make them the same person. And so in order to do this, the steps also, in a basic sense, to identify the pattern of interest and its variance. And this is always important to start off with because it can be easy to see one or two examples and want to just dive into that, right? But it's wise, and it's not always possible to exhaust all of the different possibilities, but it's wise to, you know, take a look before going headfirst into, you know, correcting the errors, because then if you only correct some of the errors and when you go back to correct others, you can like recorrect. No good. Determine your preferred substitution, and then subset and replace. Subset if need to. So here we have a dplyr example with mutate, using the gsub command, which is global substitution. There's also a sub command, which is just substitution, and it substitutes the first example only. Gsub substitutes all the examples. So we're just going to say that whenever, well, let's see. Okay. Is anybody feeling bold? Does anybody want to try to interpret this pattern? I'm going to keep asking, and I'll just, it'll be all right if nobody answers, but.
So I think you previously taught us the syntax, right? In the other. I'm guessing it's gonna be a string because it's a double dash D. That's what I
Okay,
wait,
so
can you go back to the notes?
Yeah, here I have them up. Oh, you're the
Yeah, I'm talking about those ones. Yeah, those ones.
mhm.
So I'm guessing the first three characters is digits. And then
20.
the plus, and then the plus is like you're adding them.
So it's one or more, right?
And then it's gonna be a white space plus a K.
Excellent. So I want to take any entries that have like 5,000 space K or 200 space K and make them into 1,000 K. I can also, there are also ways to do it so that I preserve that initial number with atomic groups, but that's a rabbit hole that we're not going to go down today. So let's just check this out. All right. Okay, so here, I'm gonna make this a little easier to see.
Maybe pipe it into a view with a capital V.
Yeah, could also do that. Let me just. Here. Yeah, so now we're not looking at the entire. Okay, so here we can look. So we have 2020 K, right? And so this turned into 1,000 K, right? And there's going to be more examples that are a little clearer, but this is just to kind of see how this works. And so for data table, this works similarly. This is the new variable name. This is, for those more familiar, with formal math, that is the definition symbol. And then here is the function. And then with base R, you're just defining a new variable and assigning this function applied on this variable to the new variable right here. Okay, and then so And I'm going to ask for questions just a little bit. And then so here, filtering by pattern, which is a pretty simple concept. Identify the pattern and its variance, then you filter it, right? And this can be simple, but very, very, very useful. So here in dplyr, we have just filter with grepl. Filter does not take grep, right? There are two versions. You can also use grep is also a function. It returns the index numbers, but you can't use it in filter. So because you need the Boolean. So if you're familiar with dplyr, you have this Boolean condition, and then whichever variable to apply it on. For data table, the Boolean condition goes in the rows section of the subset brackets, and base R is similar to data table. And so this is going to return any comments that end with a Latin character, no accents, no tildes, etc. So we can run this, and so here we've got me encanta, ends with an A, 996 mil, ends with an M, here ends with it, right? So we're just nothing too complicated, nothing too special, but this is basically what it does, because some of these comments end in smiley faces, right? And that is, you might not want smiley faces. Okay, and then so finally, we're gonna do a quick look behind example. Whoops. With this is a more refined example of what we were doing up here in the comments. So what this is I used data table to do this. This is taking from usernames, right? Any username that has a K in it, right? And that K is preceded by one digit and a space, right? Here, I definitely needed the Perl equals true because it's a look behind, right? So I will show this to you. And if you check this out, oh, all of these comments. Here. It's better. All right, so it got all of these guys, right? So these usernames, 1K subs without videos, right? KMN4, I don't know who that is, right? 10K subscriber. So this allows more flexibility, right? So it ends up being able to be any number of digits, and it can be any digit before this K. I just want to know that there's a digit and then a space and then a K, right? Okay, so I'm going to stop my share for a second, and I'm going to share in a more reasonable way as we go into the next part. So kind of what I was, I think for maybe a lot of us who are here, a more common use case is address data or personal data. For very obvious reasons, I couldn't use that. Right. So these are some I went into this kind of with the idea that it looks like there are a lot of bots in the YouTube comments, which should surprise no one. And so just kind of under this hypothetical of, I think these bots are going to have names like X thousand comments, likes, or whatever, and maybe they'll reply to themselves, right? I actually generated the respondents variable on my own with the most common bot, so that's just entirely made up. But just for like the purpose of creating this little scenario. So first I'm gonna look at this artificially wide data set where it gives us, and everybody can we see this better? Is this like a good size for everybody? Okay, excellent.
Fine.
And before I start with this, I'm sorry, I forgot to ask, is there any question or confusion going into this part? Okay, so first is always to identify patterns, right? So here, let's look at the column names. So these are the top, I think 25 or 30 commenters in terms of frequency in this database, right? So we have data set. We have the video name, the channel name, the comment ID, comment, date, likes, and then these are all binary variables. So if the comment was left by this this username, then a 1. If it was not left by this username, then a 0. And hopefully you don't have to deal with data that's put together like this, but like sometimes you do, sometimes one does, right? So so that's how we have it. So the first kind of venture we're going to take is how to pull these columns in particular. And then, so we're just, so of these columns, of these frequent commenters, I want to look at the comment patterns of those who I would define as bots, right? So we're looking for these 50K, 10K, 1 million subscribers, right? Like All Animals is probably, maybe they just comment a lot and people really like them, right? Good for All Animals. And Adrian Cuddliet, maybe just a real person, right? So so we're gonna ignore this. So I can put together a vector of column names, right? So we have column names and subset by 1 to 6, right? Which gives us up to likes, right? And we're going to concatenate that with the column names subset by this pattern, right? Which is kind of a double look ahead, double positive look ahead, right? So is there a space followed by a number? And so when we pull this, we get these columns, right? So now we no longer have all animals, right? We have all of these numbers, and I mean, you get 1000% luck if you subscribe, which, you know, wasn't fitting the initial pattern, but I think it kind of does, you know. And then if I want to subset the data set by bots, these potential bots, we can just assign it to a new data set by specifying these columns. And then, you know, do whatever tickles your fancy with that. And so we can also do this in dplyr, which actually wins, I think, in this task, where we can pull it all into a couple of lines, assigning to this new data set a piped condition from d comments wide, where we select columns 1 through 6, and any columns that match with this regex pattern, and Perl is true, right? Because we have these look aheads. So yeah, comment bots, right? And just kind of got this, right? And we have comments that are very light, very kind of generic. Okay, so any questions here?
I have a question for you, Sarah.
Yeah, sure.
Is there any objective or goal you have specifically with the bots, if that makes sense?
Well, this is just like an exercise. It was kind of just something I grabbed onto to focus my talk. If we were in cybersecurity, there might be, you know, or if, for example, you wanted to clean the comments for quality, to kind of eliminate bots, right, and look for comments made by humans. It might be a good technique, because I mean, there's plenty of poli-sci research that uses social media and you know, text evidence to look at tons of things, right? So that could be useful, but I mean, whatever you feel like.
Thank you.
Gaia?
Yeah, are there any practical applications of this being used right now that you can think of?
I mean, I use this all the time, right? But for example, I'm working on a data set that has just like, I think it has 132 columns of summary variables by different demographics.
Okay.
And because that's how the data was requested. And so instead of whenever I want to parse through that, I will subset the I created the variables to have predictable patterns, and so I'll subset them by whatever pattern I'm looking for, and then I can just easily get little mini data sets out of this enormous thing, right? I have.
Okay.
Does that answer your question?
Yeah, no, I was just asking, like, maybe say like YouTube and like TikTok may use this sort of thing to like filter out their comments. Like you use it for your applications, right? But I'm like to using this in like the tech world and like social media.
Oh, absolutely.
Where
I mean, I'm sorry.
No, it's fine. You can go.
No, well, so something I didn't mention is that regex is what's behind any search engine, right?
Yeah.
So Google or anything. I mean, there's more than just regex, right? When we're talking about Google, but like anytime you're searching any text, this is the code that's behind it.
Oh, yeah. Really?
Yep.
What
If
about
it's not,
like,
I mean, maybe not this particular code that I have written, right? Like, but regex is what motivates any search, any text search.
what about like AI? You know, would that tie into this in any way? Artificial.
Absolutely. Absolutely. That's a rabbit hole that we can talk about after the presentation if you want. But there's tons of different applications.
Okay. Yeah, that's fine.
So
We'll talk about it. I think Ryan has it.
Ryan, you wanna go for it?
Yeah, I haven't done regex for like, I'd say like 6 months. I know it's kind of useless in Python because you can just write that and use like libraries. But can we like just use other ways to filter, like, as you said, these comments or certain characters just by like using like syntax or like importing any like specific library, or we have to use regex?
Well, so the thing is, so if we don't use these, like a pattern like this, for example, so say we're not going to use any regex, we're just going to use characters, right? So that means the most complicated we can get is a space and then a number, right? And it has to be a specific number. So
Yeah.
I can go and I can iterate like space 1, space 2, space 3, space 4, but like I don't want to do that.
Yeah, it's kind of longer. Yeah.
What? Because once you start specifying things like \d or whatever, you start getting into regex. This is now regex. That okay, so it's just, I mean, if you can do it with a literal string, then by all means, but just it can end up being more time consuming than it originally seems.
Question. Oh, sorry.
Real quick, because we don't have too much time left.
All right, this is kind of like a dumb question, but like, could you put this into like a for loop or a while loop?
Absolutely. Absolutely. It can go anywhere you want it to go. That is the short answer.
All right. Yeah, because I was thinking like you could use it as a for loop and like put an input validation in there. Some sort of thing.
Yep, absolutely. Yep, you can use it for any
For like
kind
software
of
application.
Yep, people do that all the time. It's common use. So just not to cut you off, but just so we can get through all our examples. Here, so this is a name correction exercise that I did, and this is just an assumption. This is not based in any kind of truth other than me hypothesizing. But so there's, since we have all these weird usernames with like the 1000K likes, right? So we're looking at the data and we're looking through the usernames, and there's a lot, right? And there's 15,624, right? So, and then these in particular, loosely fit the bot criteria, right? And so I'm thinking, you know, maybe some of these usernames are actually, these different usernames are actually the same person, right? Like maybe 16,000 subs with one video challenge is the same person as 10,000 subscribers without video challenge, right? So, so here I'm going to take, let's just look at the D comments. Oops. Oops. So this is not the wide data set that we were using before. But so here we have the same, all the same initial variables. And then we have one thing that I created, which was responders, right? And so I created this imaginary world where the people who with the most frequent comments were also responding to people, right? So in that, under this kind of hypothesis of bots respond to other bots and generate more likes, right? I'm going to look at how often I think the commenter is the same as the responder. And then if I think they're the same, I'm going to change the commenter to the responder, or yeah. So for this, I use a Jarrow-Winkler distance, right, which measures the distance between strings using this string sim function. So it's a numeric value that evaluates how similar two strings are, which is another rabbit hole that I can go into after. Created a new variable, which in dplyr would be mutate name match equals, right? And then here, so what this generated is a vector of, of matching quantities, right? So I'm going to take the highest scores, except for the first score, which is 1, because that's an exact match, right? So these are similar, right? And so vsim are these high scores, right? They're 99.666. It's not a percentage, right? It's a value from 0 to 1, but these are the highest scores. That's what you need to know. And then just, I'm gonna look at the data with these high scores and see, right here we have the usernames and the responders. The usernames and responders are very similar, right? 50K, 5,000, 1,200, 1,000, 4,000, right? So I found responders that are very similar to the original comment posters, right? And so I want to so I'm going to make these all into ones, right? Because it doesn't really matter how many subscribers they are talking about gaining, right? How flexible are we on time? I have 4 minutes.
Go a little bit over. That's okay.
Okay, all right. So I'll try to go through this fairly quickly, and then also, like, I'll leave my email address if anybody has additional comments or questions. We can always chat about it later. Very happy to do so. So here we have a clean username, right? Where if the this name match variable with the score is in one of these top scores, right, we're going to substitute the first space and digit for a space and 1, right? In of the username variable. And then if it is not in vsim, then we're just going to put down the original username, right? So now I'm going to take out video name. I'm going to look at it again. And so we have username clean, and so I just basically regularized these different quantities, right? So they're just 1,000. I don't care if they're promising me 8,000 or 4,000 or 50,000. It's 1,000 something, right? And then, you know, I see kindly, right? Kindly help me. Is it different than help me? Nah, I mean, we're analyzing data. We're not in the qualitative field. So I'm just going to remove kindly, right? So if we're looking at these high frequency, high similarity names, right? Substitute the first kindly for nothing. So this, if you ever wanted to know how to delete text, this is delete, right? And if you want to delete all of the instances, we use gsub, right? And then here's what's actually. So now it's just help me, right? No more kindly. People just want to be helped. And so you can think of whatever conditions might be useful for you, right? It's almost endless. I think, I don't know if it's endless, it might be. The different combinations that you can use, but that's the basic structure of it. And then so really quick, the last thing I wanted to show, and I would be happy to circulate some of this code, is how to identify non-English characters. This is important. People write in languages that are not English. We want to see what they write. Because, so if we look at a sample of comments, right? Even, so this is in Spanish. I mean, I don't know why they wrote that, but like, this is just a sample. This is also in Spanish. Here's, we have English, but like, this is just a random sample of 15 comments out of over 19,000. And we've already found several that are not in English, right? So this is important. And regex, which I forgot to add in the little chart, has this new character class, which is the P is P backslash P, which is any character, and you can modify it with L, with N, L for letter, N for number, and this will pull anything, right? And so here it uses a look ahead combined with a look behind to kind of indirectly get at what we want, right? So this is look ahead any character that is not followed by an English character, right? So if we run this, then we get all of these nice little comments that are not in English. One, it look, you know, there's sometimes, you know, people like to use other characters, so it's not a perfect system. You still have to clean this, but it does pull other languages a little bit more faithfully. So and just to kind of demonstrate the difference, right? So this is traditional, like I'm looking for any A to Z character, no accents, no other alphabets, right? And we get 18,366 rows, right? And then once I expand it to absolutely anything, we get 19,192 rows, right? So if you're working with large samples of data trawled from social media, you could end up, I mean, it depends on what you're looking at and what you're concerned about, but you can end up, you know, eliminating a decent amount of your code. And if you ever want to do analysis on anything in another country, like not being able to specify this in regex can make your life a lot slower, right? So those are the examples I have. I'm just gonna do a real quick let's see, return to troubleshooting. I can bang this out in a couple minutes. Oops. So these are some of the most important points that issues that I've fallen into with my regex code. Making sure that Perl is true if you're doing something fancy. Oops. How do you know that this might be the problem is if your patterns are returning strange results that you were not expecting. And this is a common error that you get when Perl is not true and it needs to be true, right? Sub versus global sub. Be careful with this one. Don't use gsub when you need sub, because then you can end up changing way too many things. And this, you can only tell once you get your values back, right? Make sure to use the double backslash. If you don't, you'll get the error backslash, etc. is an unrecognized escape in character string, you know. And grep versus grepl. Grep returns index numbers, and grepl returns a Boolean. So if you're in dplyr and its filter is not working, that's probably because you're using grep instead of grepl. And grep supports the not, so like the exclamation point to negate a pattern, but it also has an argument of invert equals true. grepl does not have that option. You probably can just avoid this entirely by always using the not operator. But in case that's an error that's happened. And then here are a few resources that I will put in the chat. And that is all the material I have. I am so grateful that you all came to check out my talk. And yeah, I'm super happy to talk more about this. It's a very powerful tool. Once you get the hang of it, it's a little scary at first, but once you get the hang of it, it makes life so much easier and so much faster. So thanks so much, everybody.
Thank you so much.
Thank you, Sarah.
Thank you.
My pleasure. Here, let me put these links in the chat real quick, and then as I do, if anybody has any questions, I am happy to answer.
Do you have vectors in R?
Yes.
Ah, that's cool.
The short answer is yes. There's as with any programming language, there's a rabbit hole to go down there, but yes. Is there any other? Oh.
Is this like basic data science right here?
I'm sorry?
Is this like basic data science?
Basic, I think it's a little bit more in depth than than basic. But it's, I think, an important part of efficient cleaning, because cleaning is a basic part of data science.
All right. Kind of like you're engineering a way to like clean a comment section, like as an example you put right there.
Yeah, it's not engineering weights, but I mean, I guess actually, I mean, it could be if you want to be able
'Cause-
to weight these bots as with more frequency by combining them into a megabot and then kind of counting how often that that appears, then that could be about engineering weights.
Yeah, because it's like you're like making it more efficient, no? You're trying to be more efficient. And
Yeah,
that's
like yeah, making it more efficient. And also sometimes you have to be careful with this, right? Because this is very much the border between like quantitative and qualitative research. Qualitative research is very much about the details. Quantitative research, there's a certain point where you say, I know these things are slightly different, but for my purposes, they're the same, right?
Oh, yeah.
And this kind of helps with that. So
Thank you.
yeah, no problem.
This has been so helpful. There were a lot of little details where I was like, oh, I kind of was vaguely aware of that or something, but this really helped shore up a lot of my knowledge around regex, and this was really nice. Thank you so much.
Oh, awesome. I'm really glad you found it useful. Yeah, and again, thanks so much for inviting me. Just keep me updated with
Yeah, of
What are
course.
some projects you could make with this, like just example?
that is up to you, my friend.
So I'll tell you like one really concrete example that I feel like I use all the time in research is when I'm dealing with addresses. A lot of the times I'm already only dealing with US based addresses. So I know a lot about what to expect in them. So for example, like if I look for character substrings that are length 2, that will mostly get me state codes like TX for Texas, MA for Massachusetts, etc. And so I know I can write like a regex that looks something like, brackets alpha and then the squiggly brackets 2 to get character strings of length 2. Or like zip codes are either length 5 for the normal zip code length, or there's like zip code 5 dash and then another 4 for like a 9-digit zip code, which is less frequently used, but used in the postal system. So like I can extract those elements from addresses, and that's something I use all the time. Like it feels like not a season goes by that I don't end up using that.
Okay.
Yeah, absolutely. Yeah, but I also encourage you to like let your imagination run wild, because there's not the things that have been done are the things that someone else has thought to do, but at some point they had to think to do them. So go ahead and think your own things, can be whatever.
Okay. Well, thank you guys for your time. I really appreciate this.
Thanks.
Thank
Pleasure
you.
to meet you.
Of course.
Right.
Well, if there's no other questions, I think we can
I
wrap up.
do have one last question. Do you have like any idea if it's like a fast programming language? Because I know like C++ is kind of fast and Python is like low. So I just want to know like is R as fast or slow?
R is not the fastest. I'd say it's faster than Stata.
sure.
It depends on can go toe to toe with Python. It depends on how you're using it. Regex engines are and can be quite fast. I guess you can use
Yeah,
multiple languages. Yeah.
because I know they don't take like a lot of memory, I guess. and they are like fast. Yeah. Right.
All right. Well, if that
Awesome.
was the last question,
Yeah.
I'll see you later. Thank you so much
Perfect.
again.
See you later. Take care. Thanks again for inviting me.
Yeah, you too. Bye.